Hello, and welcome to the first class of our unit on square roots. We're going to start with a little talk about the real numbers. The first numbers we learn are called the natural numbers. These are the counting numbers. Numbers like 1, 2, 3, 4, etc. Then we talk about the whole numbers. Whole numbers include the natural numbers and 0. So that makes up the whole numbers. Then both of these sets are included in the integers. You guys have worked with integers for a while. So the integers include the natural numbers, the counting numbers 1, 2, 3, 4, etc. and 0. And then the opposites of the natural numbers. So -1, -2, -3, and so on. So the integers include the whole numbers and the opposites of the natural numbers. Now all of these are included in the rational numbers. We'll talk a little bit about rational numbers. Rational numbers up to now you've probably called fractions. Rational numbers are numbers that can be expressed as a fraction, where you have one integer divided by another integer. So that's a rational number. As long as it's an integer on top and an integer on the bottom, let's make that look a little better, you have a rational number. Now decimal fractions can be expressed this way as well. If you think about it, 0.25 actually means 25 100ths. 25 100ths. And so some decimal fractions are rational numbers. Any decimal that terminates like this, 0.125, that's a rational number. And any decimal that repeats, like 0.3, repeating, is a rational number as well. Now all these sets of numbers are included in the set of real numbers. So real numbers contain rational numbers, integers, whole numbers, and natural numbers. But real numbers also contain irrational numbers. Irrational numbers are numbers that can't be represented as an integer divided by an integer in a fraction. They're numbers like square root of 2 or pi. If you represent these as a decimal, you get a non-terminating, non-repeating decimal. Let's just do that. Let's have a look at that. Let's do the square root of 2 and calculate it. And we get a non-terminating, non-repeating decimal. Let's do pi. Again, we get a non-terminating, non-repeating decimal. And so these are irrational numbers. We're going to have to deal with irrational numbers because we're going to be working with square roots. So the real numbers contain the rational numbers, the integers, whole numbers, natural numbers, and irrational numbers. Let's talk about the difference between rational numbers and irrational numbers when we're dealing with square roots. The square root of a perfect square is a rational number. So if we take the square root of 16, we get 4, which is a rational number. If we take the square root of 9 over 25, we would get 3/5, which is a rational number. So if a number is a perfect square and you take the square root of it, you can get a rational number. If a number isn't a perfect square, like 3, then the square root of it is an irrational number. Let's look at the square root of 3. I don't know it off by heart. So there it is. 1.732050. 1.732050. 0.2050. And it continues and doesn't repeat, it doesn't terminate. So that's an irrational number. So if we take the square root of a number that's not a perfect square, something like 1.38, we get an irrational number. Let's try that one. 1.38. You can see we've got a non-terminating, non-repeating decimal. We'll do quite a bit of work with square roots in the next lesson. For now, let's complete this lesson with a little bit of a review. Rational numbers can be represented as an integer divided by an integer, and they include terminating and repeating decimals. Something like, there's a nice rational number, or there's a terminating decimal, so it's a rational number, or a repeating decimal. Let's do 1/7. 1/7 is 1.142857, all repeating. 1.142857, and it keeps repeating like that. Irrational numbers cannot be represented as an integer divided by an integer, and when you work them out, they create non-terminating, non-repeating decimals. So if we worked out square root of 2, it gives you a non-terminating, non-repeating decimal. Let's have a look. Square root of 2, 1.414, 1.414, and it continues on, doesn't terminate and doesn't repeat. Here's a few questions to think about. Just think about them and you can discuss them with your teacher. How many rational numbers are there between 1 and 10? How many irrational numbers are there between 1 and 10? If we add two rational numbers, do we always get a rational number? If we add two irrational numbers, do we always get an irrational number? So think about those, and then your teacher will take them up. That's it.